All right. Sorry for the interruption. All right. Let's go back to this again. I'm going to quickly explain this. Listening. So hopefully this pen will not get affected again. Okay. So what I was saying. What I was saying was that you have f of x. You're dilating it. If you actually read this, this is just saying 2 times whatever you're doing to the actual curve. What you're doing is we read it as dilate factor 5 from y-axis and then up by 3. Yeah? And the key part here that I want you to understand is that dilation of factor 5 from the y-axis, you're affecting your x values. So it naturally makes sense. It naturally makes sense that it goes from 0 to 5a. You're just dilating. You're stretching this area. You're multiplying this area by a factor of 5, stretching in this direction. So you're actually now just moving this to that side. And that's why the interval is from 0 to 5a. That's why this is why it is from 0 to 5a. If it wasn't from 0 to 5a, we would have an issue. But the reason why they've done that, and if it ever comes in VCAR, most likely they're going to have this dilation of factor something from the y-axis. The interval has to change. So it makes sense. They're saying find the area if you stretched it by 5 along horizontally, and then you stretch it up, as in you move it up by 3. So if I had to draw the new graph for this, this is what it looks like. I shift it up by 3, so up by 3, and this is my stretched out version. This is 5a. So I know the area is stretched out by 5, and the bottom area, which I told you I shifted up by 3, so it has this rectangular area. It's 3 times the width, and the width is 5a. So 3 times 5a is 15a. Yes, Tom?
Why don't you apply the 2 to the 3?
Or I'm just working out this first. So I'm just working out, if you're looking at this sense, I'm just saying this says double whatever this is. So I'm just sketching what that would be. Yeah. So I'm sketching what this would be. And what I can see already is you've got an area of 5a plus 15a. That's already 20a. And then what it says there is that area, now I want to stretch that vertically, or dilation of factor 2, or double your area. So whatever my area is, my current area right now is 28. That's what my area is equal to. So when you say double that, well, double that area, I'm going to get 40. So I know the area, the answer is D, just by looking at the transformations. I can picture all that. You see? Now, if you couldn't picture that, if that still doesn't make sense, we can do it algebraically to prove this. You see, if we were to do it algebraically, this is what it is. You can split up the multiplication. So you can say it's 2 times this, which is what I wrote here, and then 2 times the 3. So I split it up using the properties. We know that integration of 3, which is 3x. Oh, sorry, I'll just do this. The integration of 3 is 3x, and you sub in 0 and 5a, which is exactly what I'm describing here. This is just if you sub in 5a, it becomes 5a times 3, which gives you this area. That's the area that you're talking about. It's 15a. See, that's what I'm saying. When you shift the graph up, all you're doing is you're just taking that curve with an extra rectangle. That's all you're doing. So if you shift it by 4, it'll be 4 times 5a. If you shift it up by 10, it'll be 10 times 5a. It's times the width. Okay, that's what the rectangle part is. And then, over here, we already know 2 times, and this here is just a dilation of factor 5. So really, it's this one. And that's 5a. Now, because this is 5a and I'm doubling that, well, it makes sense that I'm now multiplying it by 5a. That makes it 10a. 10a plus 2 times 15a times 15a, that now makes it 10a plus 30a, which again is exactly what I told you. Graphically and algebraically, it's the same thing. Yes, Lachlan? As in this part? Wait, hold on a second. So you're saying if this is over 5, shouldn't the area f of x over 5 between 0 to 5a equal to a? Is that what you're asking? Sorry, can't you say it again? So if this is, so you're saying at the start, okay, that equals a. So you're asking, shouldn't this equal to, wait, are you saying that? Ah, you're saying 5x dx equals to 5a. No, because that 5a, if you just wrote 5a, this is equivalent to you saying 0 to a of f of x dx with a dilation of factor 5. You see, 5 times this is the same thing as 5 times this is equal to a, which is 5a. But when you change that, you see that is changing the domain, which now you're changing it from 0 to 5a. That's a different dilation. So what you're talking about right here is this dilation where you're stretching it up and you're keeping it from 0 to a. It's dilated by 5. So it's either you stretch it this way or you stretch it vertically. And that's what I'm saying, there's 2 dilations in this case. So you've got a dilation of factor 2 up and then 5 across. Okay? And so if I had to answer that, you could actually do it again, either graphically or algebraically. I tried to describe as much as I could in this section so you can reread it again. But that's what I'm trying to say here. If you had to take out, the only difficult part to this was the x on 5. I think the x on 5 is what is not actually described in your textbooks as well. They talk a lot about translation. They talk a lot about dilation from your x-axis, but never from your y-axis. Okay, and that's what I'm saying. You've got to take that into consideration. Yes, Corinne? Is there no way? No, well, not for this particular question, because this particular question is assessing your transformations. So understanding the properties of what a definite integral is, and then how the transformations affect that. Because what you're doing is you're moving all the coordinates according to the transformation, and hence you're finding the area of that. How does that affect the area? That's what you're generalizing. So no, in this case, you're meant to be able to read, whoops. You're meant to be able to read, oh, I can't seem to get this out. You're meant to be able to read this section and realize that's equivalent to 5 times the area horizontally. Yeah? Basha? Yes, you can. Yes, you can. Yes, you can do that. Yes. Yeah, that would be another way. Guys in the back, like I said, if you don't want to be here, get out. But for those who I'm trying to explain, it makes it harder when you're talking at the same time as well. Yeah, I've always given that option. I've marked the role. Don't want to be here, get out. That's a simple thing I can say. Yeah? Sorry, Kenny?
What I don't understand is if a on 0 of f of x equals a,
yep,
then shouldn't 5a on 0 of x on 5 equal 5a on 5, which is a?
Oh, I see what you're saying. But my question is, why was it 5a to begin with? Because you said 0 to 5a of f of x on 5, you said that this is equal to 5a and then on 5.
Yeah.
Now, why is it 5a?
Because isn't the way how you isn't it y is a because f of a equals a.
So 0 to a, this one equals to a.
Yeah.
Yeah, it does equal to a.
So f of a equals a.
F of a equals
Yeah.
a. Are you saying f of a is in capital F of a equals to a?
Yeah. Or do you not go into the complex of differentiating it and differentiating it and getting f of x?
You don't need to get the capital F. What I'm trying to say is, well, how do you know that is true? Because you're right. If you found the integral of f of x, it is capital F, and you sub a in and you sub 0 in. But what you don't know is that true? Yeah. So you don't actually know that it is actually equal to a. Yeah.
Can you create a function and then perform the transformation on it, and then see what factor of a the
Yes, and that's what Varsha was saying. You can create any function because it's a generalized one, and it should be true for every function because you're just doing a transformation.
and you see what factor of the area of the
Yeah, yeah. It should work out as well. It doesn't matter what function you choose; it should work. Yeah. Okay, so yeah, Sam.
I think it was a misinterpretation. This question arose from a misinterpretation of the transformation.
Yeah.
Because you know how it's not really x on 5s, it's x dash on 5. And that's where the confusion is.
Oh yes, because this is
Putting 5a into the function f x on 5, so f 5a on 5. But really it's x dash. So you have to rearrange the 5x.
yes,
So it's 5 times it.
yeah. That's why I said it's dilation of factor 5 from your y-axis. Yeah. And that goes back to chapter 3 instead of transformations. Okay, so you know what? I'm gonna move on from this question here. If it's still confusing, do try to read my notes here and see if it makes sense. It's draw the diagram because this whole exercise, I know it was an easy exercise. I know that you can do it, as in the arithmetic to it, but a lot of the understanding is not there. Okay, a lot of students don't understand what a definite integral is, which is why this question was done poorly. And same thing with the next question that I want to show you, which is the second one. It relates to how well you understand the notation. Can you read it and make sense out of it? Okay, so hopefully that sheds some light in terms of the graph. But I want you to have a go with the second one. Same thing with the second one here. I want you to have a go with this second one. Same thing. Read what it's trying to ask you. Read what it's trying to ask you, because if you understand what it's trying to ask you, you don't have to trial and error. Now, the best way to do this question for most students was to trial and error. And if you didn't know how to do that on your calculator, yes, it would have taken ages and you would have got the wrong answer. Most approaches to get it right was either trial and error, or you can decipher it logically. Okay? You can decipher it logically if you understand this part. This is the key part that you have to understand. You see, because you've got the same integral. You got the same integral, but it's a change of 3 to ab plus 2. And you'll want that integral to be ab plus 2 is equivalent to a plus 2 plus b plus 2. So if you visualize this graphically, okay? If you visualize this graphically, you're really just saying which one of these functions will ensure whatever function you have, you want it from 3 to ab plus 2. You're just saying that it is from a plus 2 and b plus 2. You're really, because the only difference here is you're just saying I want it to be ab equals 2, or if I write it again, ab plus 2, you want it to equal to a, oops, sorry. This is what you're really saying. You're saying a times b, because the only thing that's changed is you want a times b needs to equal to a plus b. That's what you're really just saying. From the interval there, if you just read the interval, because they're all plus 2. So the plus 2 is irrelevant. What has changed is you want this. That's the only thing that's changed. Everything else is the same. Everything else is exactly the same. So what you're really asking from this is just saying, what is the interval from AB? You want it to be equivalent to A plus B. If you use that understanding, that logic, there's only one of those functions there that can provide that. Okay, and remember, you're integrating, you're anti-diffing. Only one of those there logically will ensure that you can get that property. Okay, so have a think, and I'll tell you the answer. Okay, have a think, which one of these functions that you anti-diff that will ensure you will get this property? Because all you were looking for was the change from AB is equivalent to A plus B. Which one of those functions, logically, if you anti-diff, will give you that point? Just before the bell goes, the logical answer to this, because you want A times B equals A plus B. Now, if you anti-diff each one, we don't know how to anti-diff log in methods. You can do that in Spesh, but you can already take out B and D square root functions. If you anti-diff square root functions, you know that when you anti-diff square root functions, it's going to give you another polynomial, but it's not going to follow. It's going to be 1 on something, right? I don't care what that is. It'll be 3 on 2 or whatever it is. I don't really care, because that point, I know that graph doesn't satisfy A times B equals A plus B. But what I do know is this one, because the antidiff of this is a logarithmic function. Logarithmic function, I know that log E of A times B is equivalent to log E of A plus log E of B, which satisfies this idea that A times B is equivalent to A plus B. So then I would trial and error that question. I wouldn't trial and error the other ones. Now, I know that was a bit of a far-fetched to extend, but that's what I'm saying. Either that was the approach, or the only other approach that you could have done was trial and error. So you define a function. It could have been A, C, or E. I wouldn't have done A, B, or D. Just from logic, I could say that we wouldn't have been B or D. Okay? So you could have defined that and subbed it in to each one until it says true. And when it says true, then you got your correct answer. Alternatively, you could use what I just talked about. That's the only one that gives the log properties of m times n is equivalent to n plus n. Okay? I'll stop there. If you want the solutions to these, it's on that PowerPoint. So if you go up and download that from Schoology, it's on the PowerPoint for next ones. Okay? Thank you.